Welcome to the Weights and Measures Primer. My name is Ross Anderson. This is part 2 of the video on the Verification Scale Division E Task Group Recommendations. In part 1, I addressed the correct understanding of E relating to accuracy and precision, and I explained how this impacts measurement of error and application of tolerances. I also explained that resolution in D is independent of the accuracy in E. In Part 3, I will explore case studies showing how the principles in Part 1 are applied. In this video, I will discuss the specific recommendations of the task group as of November 2021. For the record, I am not speaking for the task group. I am speaking as the original submitter of the item and a member of the task group. In Part 1, I discussed the mistranslation of R76 in paragraphs TN12 relating to classification and TN13 relating to tolerances. I explained that the difference between D and E was blurred, and this led to the confusion. Let's dig deeper. These are all task group recommendations. I'll start with TN12 and the issues relating to classification. You might think that classes were a new concept in the 1984 replacement code. This is incorrect. Scales were classified pre-1984, but classified by application, not design. One class included vehicle, axle load, livestock, railroad track, and hopper scales other than grain hopper. These all shared a fixed 0.2% tolerance. Many other applications had a 0.1% tolerance. A good deal of this classification system remains in the code, as many requirements are still identified with the application as opposed to the accuracy class. When the translators changed E in R76 to D in the translation to TN12, they were thinking a bit like the average person, who is very likely to think of resolution as synonymous with accuracy. The proposed changes correctly tie accuracy only to E. The next series of proposed changes address S122 and the subparagraphs, but the changes require two new definitions. The auxiliary indicating device will be defined as a means to increase the resolution of the instrument display, resulting in a D smaller than E. The most common forms are the vernier for the analog instrument and the differentiated digit on the digital instrument. This is my suggested revision in yellow. The revision reflects the fact that the dynamic monorail has an auxiliary indicating device with D less than E, but does not have a differentiated least significant digit. The extended displaying device is a later addition to R76. It arrived only after the advent of the microprocessor. This is not a translation error, but a case where Handbook 44 did not keep pace. If you have worked with service people, you've seen the diagnostic tools in many weighing instruments where the resolution may be increased in test mode. In R76, this device is available to the official as well as the service technician to assist in resolving errors to at least 0.2 E without the use of error weights. You don't have to use diagnostic mode or break a seal to access it. Let's compare these two devices. Both provide finer resolution, such that the displayed D is smaller than E. The differences in blue are important. First, the auxiliary indicating device is designed to be in use at all times in both commerce and testing, while the extended displaying device is only permitted temporarily in testing. Second, the enhanced Ds of the auxiliary indicating device are subject to all requirements for D, while the enhanced Ds of the extended displaying device are not. For example, the discrimination test does not apply to the D of the extended displaying device. More on the D requirements later. When the extended D on these devices is 0.2 E or smaller, error weights are not needed in testing digital instruments, either in the NTAP lab or in the field. This is test option 2. The current S122 is a title with no text. Notice a small editorial change in the title to replace the word interval with division. The SMA has suggested using interval for all expressions of E. I suggest interval would also apply for scale divisions D. I could support this change, but it is an editorial change, not a substantive one. The major emphasis of the proposed revision is to clarify that the norm for scales is to have E equal D. The revision also relocates current S53 in this section, addressing multi-interval and multiple range scales. S53 is to be removed later. Based on the 4 types of instruments in Tables 2 and 3 in R76, there will be 3 stated exemptions to the norm that E equals D. The first exemption applies to those instruments with an auxiliary indicating device where D is less than E. These must comply with either S1221 or S122. The second exemption applies to weight classifiers, where D is greater than or equal to E. These must comply with S1223. The third exemption applies to the ungraduated instruments since they have no Ds. One final note, Class 3L is part of the norm where E equals D. However, I will explain in Part 3 that the tolerance structure has been changed to allow many more E's of tolerance. This turns out to be equivalent to having D less than E for an equivalent Class 3 instrument. In S1221, the changes are wholesale, rewriting the entire section. Here you see the original title and text is removed. The revised title now addresses the real purpose of the section, that is, to address Class 1 and 2 instruments with an auxiliary indicating device. This is a slight revision from the task group since dynamic monorails will be separated to another section. The auxiliary indicating device shall be a vernier or rider for analog or a least significant digit D that is differentiated in size and color for digital. I'll discuss the differentiated least significant digit more in Part 3. A differentiated digit helps avoid the possibility that the official incorrectly assumes that E equals D without looking at the scale markings. There are 2 requirements. In A, E must be greater than D and less than or equal to 10D, and in B, the E must be a 1. 2s and 5s are not permitted. When you evaluate E equals 10 to the K power, when K is an integer or 0, it will always be a 1, as in 0.01, 0.1, 1, 10, 100. There are 2 exceptions not addressed by the task group in yellow. Subpart A does not apply to a Class 1 scale with E equal 1 milligram. There is no lower limit on the size of D. This was lost in translation from R76. The key is that E can never be less than 1 milligram because that's the smallest weight we can practically use in testing. Yet we may want to have scales with resolution D down to a microgram or even less. When D is a microgram, E equals 1000 D. The test still ensures that the Ds are uniform and accurate. The examples are provided to aid in understanding. Since Class 3 and 4 instruments are addressed in the revised S122, this section will be changed to address dynamic monorail scales. Current dynamic monorails have D finer than E. The change to allow an extended displaying device would now make it possible to have E equal D. I'll explain the extended displaying device shortly and also in Part 3. For a dynamic monorail with an auxiliary indicating device, D shall be smaller than E, but unlike Class 1 or 2, E does not have to be a 1, and there's no requirement to differentiate D. Weight classifiers are often misunderstood. While the code includes them, officials rarely encounter them. Weight classifiers are marked for special use because they round up. Normal half-up, half-down rounding scales, typically with much smaller D, may be used in the same applications without special use markings. The divisions D must be equal to or larger than E. Just how much larger is unrestricted. We have to be careful in testing, as the rounding is not always 100% up. The option 1 test procedure using error weights accounts for this rounding when properly performed. The weight values expressed in D's are the basis of the commercial transaction. In this new section for weight classifiers, E shall be equal to or less than D. The task group proposal no longer limits weight classifiers to classes 3 and 4. The new S1224 addresses the specifications for the extended displaying device. First, these are not permitted on devices with an auxiliary indicating device. It would be redundant. When so equipped, the extended display may only be visible while pressing a key or for up to 5 seconds after entry of a manual command. To prevent fraud and confusion, the instrument may not print or transfer data while the device is in operation. It is simply a tool for the person performing the test. I suspect these will rapidly become standard features since they make error weights unnecessary. Since the size relationship of D and E is explained fully in the revised specifications, it is unnecessary to state anything about D in the definition of E. The proposal is to remove the last sentence. Generally, it's poor construction to include technical requirements in definitions. In the current Table 3, Column 2 is expressed in D or E, but the verification scale division is E and not D. Next, notice that the N in columns 3 and 4 is capacity divided by E, not by D. The table is a mixed metaphor as written. See why people get confused? The revised table will reference only E in column 2, and the word verification has been added to the header for columns 3 and 4. A parallel revision to the definition of N will be explained shortly. The task group proposed revision to 2 notes to Table 3. In Note 1, we replace the current text entirely because it is confusing, to direct the official to use the value of E as declared by the manufacturer in the marking requirements. The reference to Notes 3 and 4 in Table S63B is the cross-reference to the marking requirements. I'll cover that shortly. I note an SMA suggestion to add to the first note that the manufacturer may have E different from D. I contend this is unnecessary since it is addressed in the revised S122. In Note 3, the divisions for classification are all verification scale divisions E. One of the important ripple effects of these changes is in markings. The current code requires that every instrument be marked with class, capacity, and D. How do you even do that for a balancing instrument that has no Ds? In R76, the manufacturer declares class, max, and E, since these 3 define both the classification and the accuracy and precision. A balancing instrument must be marked with E. The marking of D is only required in R76 when it exists and is different from E. The proposed change required that both D and E in Table 63A be tied to Notes 3 and 4 in Table S63B. I'll show you why. These are the current versions of Notes 3 and 4 in Table S63B. Currently, D is the primary marking and E is supplemental when different. The proposed change reflects a desire to make E the primary marking and D supplemental. A second minor problem involved multiple range and multi-interval scales, the underlined part of Note 3. The text now requires scale division D and weight unit. A weight unit is a pound or a kilogram. The text does not really say what is intended, namely that capacity and verification scale division E be marked for each range or partial range. Revising these 2 notes presented the task group with a challenge because they did not want to impact the non-retroactivity dates. The proposed solution in Note 3 expands possible compliance. It has no negative impact on existing equipment. The proposed changes: 1. Allow for the use of the OIML term max for capacity. Note this is in a retroactive section. 2. Permit marking of either D or E for instruments where D and E are required to be equal. Remember the corresponding change to S122. 3. The 30 by 0.01 pound example is removed as it is redundant. 4. For multiple range and multi-interval scales, each D or E with its associated capacity shall be marked. The value of E must always equal D for each range or partial range for these instruments. And 5. The highlighted text is my addition. You are referred to Note 4 for any instrument where E is not required to equal D. The proposed change into Note 4 include the exceptions to Note 3, where E is not required to equal D, and these parallel the 3 exemptions in S122. In A, scales equipped with an auxiliary indicating device must have marking of capacity with both E and D. In B, there are 2 cases for the weight classifier. Where E equals D, it requires marking of capacity and either E or D, similar to Note 3. Where D is greater than E, it requires marking of capacity and both E and D. In C, ungraduated instruments must have marking of capacity and E. These instruments have no Ds. As in Note 3, the non-retroactive date is unaffected, as these paragraphs are just more detailed explanations of the case where E is not required to equal D. We're saying it differently and hopefully much more clearly. The requirements in S53 were incorporated in the revised S122 and S1221. Accordingly, S53 is being removed. The proposal renumbers S54 to S53 and changes any reference to D to E. The load cell verification interval is parallel to the verification scale division E for the instrument. The SMA has proposed the use of interval in the name of E would strengthen this connection between V and E and further differentiate them from D. The correct reference to E allows us to consistently apply this section without having to sometimes use D and other times E. The last part of the task group recommendations for classification addresses minimum load. Accuracy is not the sole determination of instrument suitability. You must also consider the resolution in D. You will find, as a general rule, the greater the relative value of the commodity or service, the finer the resolution in D and the relative accuracy in E and N. We don't use Class 1 scales to weigh gravel or Class 3L scales to weigh diamonds. This is what Table 7a is trying to address. I'll show that the minimum load relates to rounding errors to D and not accuracy to E. This is the proposed change to the user requirement from Handbook 44. This section gives the underlying reasons for the Table 8 values as the likelihood of relatively large errors at light loads. The proposal is to change the wording slightly. Where would the relatively large errors in the current text come from? I return to a graphic from Part 1. Notice the errors in the vicinity of min. For Class 2, min is 50D. Now remember that errors do not invade the shaded areas under the riser. Can you see any relatively large errors down there? Several comments on the original proposal mentioned that errors could reach 1E at these loads. Commenters were focused on the tolerances and not on the errors that are likely. To focus on the tolerance down there is misleading. I'm not asking you to take my word for it. I'm very confident if you test down there to 0.2E, you will find the error is very close to 0. So let's look at it with our error model in the case where E equals D. You'll see that the 50D analog graduation, or the center of the 50D digital division, will align closely with the 50E test load within 0.01E, essentially zero error of indication. Returning to my theme, was something lost in translation? Consider the parallel text from R76. The underlined expression considerable relative errors got translated as relatively large errors. They switched the position of the relative in the phrase. I think the switch changed the meaning. Look again at 50D on the instrument scale. The minimum load is not addressing the error of indication, which is essentially zero. Rather, it's addressing the rounding error when the instrument is used in commerce. The actual load can be anywhere within the scale division D. The transaction error at any load is thus a combination of rounding error and the error of indication. Let's look at that in another way. Percent error of indication at light loads is essentially zero, the red line, and superimposed over this error is the rounding error in blue. The relative error due to rounding appears as a sawtooth curve. Within the 50D division, it ranges from plus 1% at the lower boundary to minus 1% at the upper boundary. This is one reason we eliminate rounding errors in tests. Notice that the sawtooth peaks are larger moving left and smaller moving right. What R76 is doing, and what Handbook 44 should be doing, is ensuring the rounding error to the scale division D is small enough at light loads. Here you can see how the rounding error compares to the relative accuracy of the class. While the 1% relative error for class 2 might seem large, remember that it is 1% of a very small quantity. This graph should help. The amber line for percent error of indication for class 2 was discussed in part 1. Focus now on the purple line describing the rounding error of 1/2 D for the case where E equals D. At 1E load, the rounding error of 1/2 D is 50% relative error. For R76, a considerable relative error. The rounding error tapers down rapidly and reaches 1% at 50D, the minimum value of min for class 2. At $20 per gram, the rounding error of 1% of a 5-gram minimum load is $1 for a $100 transaction. Now observe the turquoise line, describing the rounding error of 1/2 D, where E equals 10D. The rounding error has dropped by a factor of 10. In this case, you reach 1% rounding error at 5E load, but still 50D. The higher resolution allows you to use the instrument for smaller loads and reduces the price increments in the transaction. At $20 per gram, the 1% rounding error at 0.5 gram minimum load is 10 cents for a $10 transaction. Upscale at 5 gram load or 50E, the rounding error is 0.1% or 10 cents on a $100 transaction. Some may still be unconvinced. They will point to R76 Table 3 and show that the min is specified in E, but did they read critically? There are two exceptions to the table. The first exception is beneath the table and creates a special 5E min for weight classifier, what R76 calls a grading instrument. This is related to the roundup. The other exception is found in 3.4.3. Note all of these are in the metrological requirements or closest to Handbook 44 notes. For an instrument with an auxiliary indicating device, E is replaced by D in column 5 to calculate the lower limit of min. How should we interpret all this? You have to consider 4 kinds of instruments as in the revised S122. R76 includes the normal resolution instruments and the balancing instruments in the body of the table in E. It covers the high resolution by switching to D in the table by exception. it creates a special exemption for weight classifiers of 5E. Notice two kinds in the table and two kinds by exception. Currently, in Handbook 44, only the normal resolution matches R76, since E and D are equal for these instruments. You'll notice the high resolution is a question mark, as the practice is to use E in column 3, yet the code does not say that clearly. With the proposed Table 8, all four kinds match R76, although stated slightly differently. The normal resolution and high resolution are in the table in D. This makes sense since the issue is rounding error and we are rounding to the scale division D. The balancing instruments are in the table in E by exception, as they have no Ds. The weight classifiers that round up now match R76 at 5E. Here are the changes to Table 8. Column 2 will be identical to Column 2 in Table 3, expressed only in E for classification. The recommended values for min in Column 3 are now in D. Note 1 has been changed parallel to Note 1 in Table 3. It directs you to use the marked values of E and D as appropriate. The note for the balancing instruments directs you to switch to E in Column 3 because the rounding is to the sensitivity E of the balance indicator. More on this later. The last note addresses the weight classifiers with a 5E min. To conclude the discussion of min, I'd like to make a pitch for the R76 approach to require marking of minimum load. This is not yet a formal proposal. In R76, classification is expressed in markings of class, max, min, and E, referred to R76 Table 3. Users of R76 instruments know what min is by this marking. Handbook 44 requires no marking of min, and thus virtually all users in the U.S. are unaware that an instrument has a lower limit. The marking would become part of the manufacturer's specifications, impacting the instrument selection, and every user would see the minimum load on the face of the instrument. In Part 1, I explained that tolerances, the limits to accuracy, are expressed and measured in units of E, the verification scale division. But keep in mind that it is relative error we're interested in, that is, the combination of error in E and load in E. So how do we fix the code? The task group is recommending that we remove any mention of D in TN13 and that the language indicate that tolerance is not related to E, but rather expressed as a small number of E's. The underlined phrase comes from R76. This change brings to light a significant mistranslation in the definition of N. Without the word verification, N is the number of D's. The definition conflicts with itself. The scale division is D, yet the formula in the definition states that N is capacity divided by E. The fix is in the lower added definition. The correct term is verification scale division, number of, parentheses, N. We could have deleted the upper definition. It was retained and modified as a placeholder in the S's alphabetically. You are directed to the V's alphabetically for the definitions of E and N. We now come to the major mistranslation in the current code, Table 6. All values in the tolerance table are currently specified in scale divisions in blue, and this is by definition D. This has been wrong since 1984 and is the primary cause of our confusion. All values in the table will now be in E. As revised, test loads and tolerances are expressed in E's of actual weight. Notice the Class 3L section in the lower right where E is specified instead of D. There are ripple effects to this change. Manufacturers never declared E for unmarked scales, since E did not exist before 1984. We face a problem as the tolerances for many unmarked scales are found in Table 6 in the TN section. The proposed change clarifies that whenever the T section refers to the TN section, it is accepted that E equals the scale division D. Many of the current TN tolerance paragraphs refer to specific tolerances in D. The task group is proposing that we revise all of these so the tolerances are expressed in terms of E. Here are two cases. There are several other instances, and they are all identified in the proposal. The task group discovered a significant problem relating to accuracy in S111B. Here is the current text. To be accurate, a digital instrument must start at what we refer to as center zero. The analog equivalent is to start at the zero graduation. This paragraph was an attempt to ensure an accurate digital zero, but omissions and mistranslations from R76 changed the meaning. The initial text in Part B addresses maintaining center zero, but was something left out about how it got to center zero in the first place? Next, notice the underlying text. Does this auxiliary or supplemental center zero indicator imply one exemption from the maintenance requirement or two? It has traditionally been interpreted as one exemption for a zero tracking device. Here are the related R76 sections. Section 452 is an accuracy requirement for zero setting to 1/4 E. This is a technical requirement directed to the manufacturer. For analog, it requires the manual adjustment permit zero setting within 1/4 E. For digital instruments, the manufacturer must ensure accurate 0 to 1/4 E after using initial, automatic, or semi-automatic zero setting devices. Section 455 is a requirement to indicate when the digital device is at center zero within 1/4 E. This is not a requirement to maintain center zero, but take careful note of the exemptions, plural. The center zero signal is not mandatory if the instrument has an auxiliary indicating device or a zero tracking device. Two exemptions for two very different things. This is not at all clear from the current text of S111B. Any instrument equipped with an auxiliary indicating device will provide a non-zero indication if the instrument is not within 1/4 E of zero. Here's the proposed revision to S111, but not showing the text removed. Essentially, the B section is repealed and split into two new sections. The new B requires zero setting to be accurate within 1/4 E. The language is taken verbatim from R76. The new C requires a center zero indicator with two exemptions. No center zero indicator is required if the instrument has either an auxiliary indicating device or a zero tracking device. The proposed language is very close to R76. This concludes the tolerance issues. Another part of the charge to the task group involved clarifying the application of requirements to D or E as appropriate. The distinction relates back to the issues of accuracy and precision in E and resolution in D. Here's a list of other sections and a clarification of whether E or D applies. I'll only mention a few of them, but please pause the video if you need to study the table in more detail. S111A addresses the zero division D of the instrument. Center zero sets up the normal rounding, half up, half down. S121 addresses indications of gross, net, and tear, which are in displayed divisions D. Note again that division D is always used in the transaction. S17B addresses overcapacity of 9D, which the test group chose to leave unchanged. The R76 requirement is 9E. We may want to revisit this. Continuing the table, T2 and TN61 both address test loads for the sensitivity test. All test loads should be actual weight in E. This is not addressed in the test group recommendations. TN7 addresses discrimination of the scale division D. It is D in R76 as well. Also note that requirements of D do not apply to the extended displaying device, particularly TN7 discrimination and GS523 uniformity of the size of divisions. UR310 will be discussed in Part 3. It reflects the misunderstanding of E and D. These instruments currently use an auxiliary indicating device with D smaller than E, but demand you conduct the transaction in E's. This is confusing, and the task group earmarked this for further study. I would summarize the consequences of the proposed changes as follows. E is not the object of verification, but a tool used in the verification of the indications in Ds. E is not found on the instrument weight display. Remember the ungraduated instruments with no Ds and the weight classifiers with the least significant D may be much larger than E. Test loads and tolerances refer to actual weights embodied in the test weights and test loads in E. The verification of an indicating instrument ensures relative accuracy, meaning the weight values in Ds are accurate. Commercial transactions should always be based on the indicated weight to a least significant digit D. The balancing instruments are an exception, where the transaction is based on the counterbalance weights or actual weight in E. Maybe the best way to think about this is to recognize that E's and D's are for the person testing the instrument. They are not used by either buyer or seller who deal only in weight units. I'll wrap this up by noting there are a lot of subtle changes being proposed. They have very little impact on manufacturers or users. Manufacturers were, for the most part, following R76 principles all along. International manufacturers may benefit from some reduction in differences between Handbook 44 and R76. Users are largely unaffected by these changes, but might benefit from a future change to require marking of min. Virtually all of these changes are directed to the official to reduce confusion. The parallel R76 sections were mostly found in the metrological requirements. These are closest to notes and tolerances in Handbook 44. I believe these changes with a slightly revised training program would serve to eliminate the accuracy versus resolution confusion that has been plaguing us. I'm already planning to produce a video on how to teach verification, which will include the scale code structure after these changes are enacted. Thank you for listening. Please come back for Part 3, where I explore some case studies applying the principles of the scales code discussed in Part 1.